If you are a .NET developer, then you have an edge
So
over
I made
every
this
other person
video
that is
about a year
learning machine
ago,
learning
and that
without
is
being
how
a
to
.NET
build a
developer.
machine learning model
You may have
using
heard of
.NET
people
if you are a
using Python
developer.
and TensorFlow to
Now
build
I'm going
machine learning
to
model.
stop
I
this,
also did the same thing, but I
and
tell
I'm
you,
going to show
if you are
you
a .NET
a
developer,
different way to
you can
do this.
actually do the same thing in
The
.NET.
reason is because Microsoft kind of screwed things up. They try to improve the way to build models, machine learning models, using C# programming language. So I'm going to actually stop this, and these are the steps that you follow in this previous lesson that you just saw. I played back right now. And you can see that we actually completed this building this model in .NET. It was super easy, and that's the benefit of using Microsoft technologies. They are super easy to use. Now, if you are a developer already, you use Visual Studio, you are a C# developer, ASP.NET developer, then you don't have problem. You are halfway to becoming a data scientist. You don't have to go back to learn Python or to learn Keras or Jupyter Notebook. You can maintain the pace using Microsoft products, and that is great because Microsoft keeps improving every time. Although they screw things up a bit simply to be able to improve, they keep changing things and sometimes they break some things. But Microsoft products are super easy to use if you want to become a data scientist or a machine learning expert. So let's get started. We are not going to follow this procedure you see here. We are going to follow a procedure available in 2019, which is actually a bit different than this one, but it's all the same. You have to learn how to use what you have, Microsoft tools, to build our machine learning models. If you are just joining my lesson for the first time, hit the subscribe button below, subscribe to my channel, and in that case, you keep updated when a new lesson comes out. And if you have any challenges, also leave me the comment below in the comment box below, so that I give you the necessary support you need to be able to do what you want to do. I'm always here to support you. I make this lesson for free. I'm not paid for this lesson. So feel free to leave me a comment. Also visit my website. You find it in the description box below, kindtonthegenius.com, and you can see a link say buy me a coffee. Maybe I'll just go there at once. So you can visit kindtonthegenius.com. If you go there, you can see a variety of topics you can learn for free. Anything you want to learn, programming, Java, Node.js, Spring Boot, everything. And then you can buy me a coffee. You can see buy me a coffee, click buy me a coffee and buy me a coffee if you want to support me. All right, let's get started. Now, I've outlined the steps to build this model in a step-by-step way right here on this page. So these are the steps we are going to follow. We are going to follow these steps. We are not going to skip any step. We are going to follow it one step at a time until we build a machine learning model. What kind of model are we going to build? We are going to build a model to perform clustering. We have a data set made up of different categories of data. We are going to perform unsupervised learning to be able to determine what clusters it belongs, the data set belongs. The same data set can also be used to perform classification because it is the iris data set, which are a collection of flowers belonging to three different categories. All right, so let's get started. We are going to do step by step. Prerequisite, you need to download Visual Studio Community Edition. It's free. If you already have Visual Studio 2013, 2013, not sure it's going to work. 2017 Community Edition is free. Download it and install it in your system. If you're a newbie, a beginner programmer, you can follow this lesson because it's a step-by-step. Also, hit the subscribe button below so that you don't miss an update because this is really easy to follow. I would like to recommend you subscribe and leave me a comment if you have any recommendation. Right now, I'm going to start Visual Studio 2017. That is what I have. Visual Studio 2017. Let's go down. All right. So Visual Studio 2017. I'm going to click on it. And we are going to start a brand new solution. And while Visual Studio is opening, I would like to mention the data set that we normally use. The data set is called the iris data set. It comes as a text file. It also comes as a .data file. I'd like to show you, I'll actually open it from my system here and actually show you how it is. So if I go to my drive D, I go to data, and I can just open up the iris data set right here, iris.data. And you can see it's a fairly simple data set made up of 5 columns, 4 features, and 1 class. All right, so we are going to see more about this data set as we move. So let's follow it step by step. So I'm going to restore this kind of so that it fits into it fits in the screen side by side with the procedure. So let me just place it right here, and I'm going to drag this one down. I didn't know my system trying to be misbehaving this time. This is a fairly good system I have. All right, so the data set, I'm going to shift to step 1. The data set is a collection of flowers called iris. There are 5 columns and 150 rows. You can download this data set if you are in this website, KmeansGenius.com. Now, Datamatics.com. Actually, look at the description box, you'll find the link to this place. You can download this data set by clicking on this link. If you click on this link, you have this data set downloaded. Save it somewhere in your system, maybe in your Drive D, in your document folder, and have it there. And try to examine this data set. Open it in text file in Notepad and try to see what is in there. So the first thing we want to do, one thing I want you to pay attention to is errors that are going to occur. Because these errors are going to occur and we need to fix them. So I'm not going to actually cut out in this video where errors occur and I fix them. I'll make you see the errors that occur and see how to fix them by yourself without skipping any step at all. So we are going to be working raw in real time with everything clearly explained. All right, so I'm going to just drag this. All right, so step 1, the second step says create a console application. Let me just, okay, perfect. All right, so let's go to create a console application. Go to File and just click on New and choose Project, and it's gonna be a console application. So leave it in the second one. The second one is okay, .NET Framework. If you use .NET Core, I've not tried it, but I don't know, I think it will work. After now, maybe I'm going to do it. Or if you use .NET Core and it works, leave me a comment to let me know it works. So I'm going to call it ML tutorial 1, because I actually have to make other tutorials. So let's call it tutorial 1. And this .NET console application right here, I'm going to just say okay. So now the next step says I've created this console application. I think it's starting up, as you can see. I'm going to create a folder in the application called data. Actually, you can create a folder and give it a name, but I want to give it a name data, and I recommend if you give it the same name I gave, that is going to be very fine. So now our project is ready, the solution is ready right here. I'm going to just right click and create a folder called data. So let's go to add folder, new folder, and call it data. This is where I'm going to place my data set. Because we downloaded this data set, we are going to copy it right inside here very easily. And the next thing we want to do, copy the iris data file into this folder. So I'm going to just right click on the folder and say add and choose existing item. I'm going to browse to where I saved the original iris data set I downloaded, and I saved this somewhere in my documents. No, in my Drive D under data, and actually I'm going to drop down here and choose all files because this is .data file. So the name is iris.data, as you can see right here, and I'm going to just add it to my project, and you can see it's added there. There's some change you need to make, very important. If you miss out making this change, it's not going to work. Just right click on the iris.data file, go down to copy to output directory and choose copy always, or copy if newer. Any of them is okay. Perfect. So now we've done this, and that is fine. I'm going to just close it because everything is fine. There's something called reference management. So it's similar to dependency management in Java. So we have references to your project. There are some external references your project uses, and this can be managed using package.config or package reference. So the recommended way to manage it is package reference. If you use package.config, you may have errors. Microsoft tries to force developers to do what they think is the right thing instead of doing what you are used to. And that is something I find kind of restrictive sometimes. So I'm just going to right click on references. This is now step 5. And no, sorry, I'm going to right click on my solution and I'm going to choose. Okay, so this actually I've already migrated it to package reference, but if you have a menu here that says migrate from package.config to package reference, click on it and migrate your references to package reference. Now I think my Visual Studio is configured already to use package reference to manage the references here. Alright, so add ml.net nugget package to your project. So I'm going to just right click here and choose manage nugget packages, and at that point it shows up here and I'm going to click on browse and choose Microsoft.ml, which is the first one, Microsoft.ml. This is a package that contains the tools that you need to build machine learning models in .NET. So I'm going to click on it. I'm going to install the latest version, which is 1.3.1. So just click on install. It's going to bring up, it says, okay, manage project with package reference are not supported in Visual Studio 2015 or earlier, so that is fine. We are using 2017. So select the package manager. So you're going to see this. You can see I'm going to use package reference. It's better than package.config, packages.config. I'm going to say OK. Now at this point, it's going to bring up some licensing pop-up so that we can accept. And I just click on accept here, and it's installed. If you are looking at the output here, successfully installed, and you can see everything was successfully installed perfectly. All right, so I'm going to just close the Nugget packages console, and I'm going to kind of build the application, build solution to just make sure everything is okay. Take a look at the output of the build, and you see that it succeeded correctly. Now we are going to create two classes. One class represents the feature set or the predictor variable. The other class represents the variable, the classes or the target variable. So what they're saying is that if you have a data set like this, the classes are the names of the flowers that each data set, each feature belongs. So have 4.6, 3.4, 1.4, 0.3. Given this collection of features, what class or what label does it belong? Does it belong to Cytosa? Does it belong to Vesicolor, or does it belong to Virginica? So this is the decision that has to be made during classification. But what we are doing today is clustering. And also check next, I'm going to bring up another video, a lesson for classification. All right, so we are going to create two classes, one class to hold the feature set and one class to hold the prediction or the labels or the classes. All right, as I said, the classes are just the last column in the data set. All right, so I'm going to close this. I'm going to right click a solution and choose add class, and I'm going to call it iris data. And I'm going to call it iris data. So this class is going to represent the feature set that we are going to use to predict the class. So just go to add. And now the feature set, you have to define it exactly the same as the features in the data set. So we have 4 columns in the data set representing all the features. So instead of to kind of type them out, I'm going to just copy it and paste. But for you, I recommend you type it out so that you kind of appreciate how this works. So just paste it in here, Control V. Now, yeah, so I know that this error might occur. So what I'm going to do, I'm going to first save everything. And to solve this problem, remember I told you we are going to be solving problems at this point. So just check whether you have namespace load. Okay, show the fixes here. And using Microsoft.ml.data, that is what you are going to click. So it adds the namespace where we have the load column. So Microsoft.ml, the data is added there. And we are going to add the other class, which represents the labels or the classes. And I'm going to right click and say add new class. So I'm going to call it cluster prediction. So the idea is if you are given a new data, a new feature set, you're going to predict the cluster it belongs, given 3 clusters. We're going to talk about this later. We're going to call this cluster prediction. All right. So the cluster prediction is going to have, instead of 1 column, it's going to have 2. The first column is a predicted cluster because we are given 3 clusters. And the second one is the distance, is an array of distances. I think I should illustrate this, but let me add this class first because I want you to understand it perfectly well. So I'm going to save. Okay. Again, we are going to do the same thing using ml.data. Solved. So permit me to just explain to you what these distances mean. So I'm going to just use paints. Paints. All right. So now, if you have a data set and we are performing K-means clustering, let me just take a pen. So assuming we plot a data set in this way, all right, and you have 3 clusters, cluster 1, cluster 2, and cluster 3, okay? So if you are given a new data set, let's say a data set at this point, we have X, P, given a new data set at this point, you need to check the distances from each of the cluster. You check the distance from each of the cluster centroids, and the one that have the shortest distance is the cluster it belongs, right? So in this case, if we have this to be cluster 1, we have this cluster 2, we have this to be cluster 3, then XP belongs to cluster 3. That is how clustering works in machine learning. So I'm not going to spend time in this because I'm not doing the theory of K-means clustering. All right, so the prediction is given, and the distances, the squared Euclidean distances, square distances from each of the cluster is also given as an array. So you, as machine learning or data scientist, will also see the basis why the model predicted what it predicted. So, so this is it. The next thing we are going to be doing, okay, there is the explanation of what I just told you right now. We need to define the data model and the data model part. This is done in the program.cs file. We add 2 static fields. One of them represents the path to the data set, and the other one represents the path to where the model will be saved. So it's also clear. I'm not going to spend time explaining all this. So I'm going to just copy these 2. When we paste it, it becomes clearer. So never mind. I'm going to go here. I'm just going to come to right here, just above the main method, and just paste it. And I'm going to just shift this a bit. Okay, so so maybe I'm going to reduce the font of this so that everything fits in. I'm going to shift this. Okay. All right, so we can see we've created 2 parts. One is data part and one is model part. Data part contains the data set we have. Model part contains the part where the model is saved, because when you are training the model, the data and the model have to be in locations that is in the class part, not in external locations. I'm going to save everything, and I'm going to add the 2 namespaces, system and system.io, because that is where the path is defined. So just show potential fixes and say using system.io, and yeah, so it's added. All right, so the next thing we want to do is to create a machine learning context. A machine learning context is just an environment where the model will be developed and trained. It's similar to TensorFlow. If you've been following my lessons in TensorFlow, it's similar to the TensorFlow environment we created in Anaconda. ML context, or the machine learning context, provide features for logging, for loading the data, for training the data, for prediction, and a few other things. It's similar to DB context in Entity Framework. So to do that, you simply create a new context. It's just one line. And now we are going to be doing all of this inside the main method. So we are going to do this inside the main method. We've created a context. Ouch. So I'm actually putting it outside the braces. So it's going to be actually inside the braces like this. I'm going to maybe put a comment, maybe not. So the comment, you can put it by yourself because you have all the explanations here in my website. The next step, step 6 of phase 6, means load the data set into the workspace. Now we are going to load up the data set, and we are going to use a function called load from text files. It's a method available in the data context. So data context we mentioned, it helps you to load data. When this function called load from text file runs, it returns an iDataView object, which actually is a container for holding data that is ready for training. So I'm going to just copy it and paste, then we try to examine it. So this, we have ML context, we have error here. Using Microsoft.ml, okay, so you know how to solve problems at this point. Alright, so let me just shift this, maybe we can see everything at once, and maybe reduce the font size of this. Okay. So I have the code to load the data on my clipboard, and I've actually pasted this code. So as I mentioned, an iDataView object is returned by load from text files. So whatever happens load from text files, it's loaded into the iDataView object. All right, so is it possible to see what this data is? No, we can only see it in runtime. So it's the same as the data in the text file, but is in a different format at this point, ready to be used for training. Now we need to create a learning pipeline. If you followed my previous tutorial where I did last year in 2018, you see that the steps in creating a pipeline was quite easier. When you create a pipeline, you simply specify the data from the text files, not an iDataView. You specify the path to the data, but in this case, we are not specifying the path to the data. We are specifying the iData, we are specifying the column definitions or the feature definition. Now I'm going to start by copying the tool, and then I explain it a little more. So the steps, there are two steps. One, concatenate the 4 features into one, and use Kmeans Trainer to train the model at this point. So if you want to read more about Kmeans Trainer, you have a link here. Just go ahead to click. So I'm going to just paste. So this is quite straightforward as well. So we are creating feature columns object and feature columns name, and we are calling it features. And now we have pipeline is equal to ML context that transforms dot concatenate the feature columns name, that is the features, and we concatenate the 4, and then we append the ML context clustering the trainers that Kmeans. Now there are other trainers. I recommend you try to check them out. There are other models that you can build. For instance, if you put a dot here, we have binary classification, we have clustering, we have component catalog, we have multi-class classification, ranking, regression. There are other things we are going to do. So there are a rich set of activities we are going to be engaging in ML.NET. You simply need to hit the subscribe button and let me know what you think. And at this point, we are only performing clustering. After now, we are going to try to perform classification. So keep subscribed. All right, so as you know, a number of clusters has to be specified in K-means clustering. One thing you need to know is that if you are doing K-means clustering, instead of doing hierarchical clustering, you need to specify the initial number of clusters for the K-means clustering. Here we are specifying the initial number of clustering to be 3. We want to keep it simple. And having created the pipeline, the next thing is to train and save the model. The pipeline is something that helps you train the model. Like a neural network, you move from the input layer to the output. So again, maybe I'll just illustrate. You know that in neural network, you have something like this. And that is what we are talking about. We have this. We have hidden layer. We have output layer. We have some input layer. And we have the input, maybe x1, x1, x2. It goes through the hidden layers, and then it spits out an output, let's say y1 and y2. So this is a pipeline. A learning pipeline moves the data from the input all the way to the output, and that is what we call neural network in theoretical when we are talking about the theories of machine learning. All right, so we need to now train the data set. So simply one line. You already know that to train a data set is very easy. You simply use the pipeline.fit. So this is something you should know. In every analysis, you fit your data set using the model you created. So in this case, we are saying pipeline.fit. In regression, we say model.fit. That is Python. So I was saying, if you know ML.NET as a developer, you're halfway done. Simply follow my lessons and you are done. And learning Python will be in your fingertips. It's going to be very easy for you to do. All right, so we've trained our model and now we are going to save our model at this point. The code takes a while to execute. That is this piece of code you have. At completion, the model will be ready. We can now save it to the directory we created. We say that we save the directory, we save it in model paths. So you can see model paths right here. And you just shift this one downward. Model path where the model is going to be saved. All right, so I'm going to just copy this. So we are now saving the model and also saving we are saving the model at this point. So let's see. Actually, we are saving the model means also creating a file in the file system. So I'm going to just shift this. All right. So when you want to create a model, we are using statement so that if any error occurs, because we are working with the file system, an error might occur, so that we are using statement. File stream is new file stream is created. We provide a path, provide the file mode, we provide the access read, the file. We also say share, so that our Visual Studio and our model will be able to write in the model into this file that we are going to create. And after then we say ml context.model.save. We give it the model, we give it the data view schema and the file stream. So I'm not going into the theories of this for now because I want you to run through this to see how easy it is to build a machine learning model in .NET. It's very, very easy for everyone to do. After now, we are going to maybe drill deep to see if we can understand a little more. Now we are going to make prediction. To make prediction using the model, we use the prediction engine. See, Microsoft ML have a whole lot of things you need to learn, but don't worry yourself. We are going to be talking about this in details a little later. We use the prediction engine class. Prediction engine will require the source and the destination. What does this mean? You need to use it to take an input instance, a single input that is a new data point at this time, that is not in the original training data set, and we need the destination where it's going to give us the predicted output. All right, so the first step is to create a prediction engine. So I'm going to just create the prediction engine at this point. So I'm going to paste it. So it's predictor, I call it iris prediction. So iris prediction is not the real name. The iris prediction is supposed to be iris clustering. That's the name, I think. The name of the class we created let's see, iris prediction or cluster prediction. Yeah. So remember, originally we created a class that represents the output that contains the predicted label and the score, okay, or the distances, not the score, predicted cluster and the distance from all the clusters. So cluster prediction. All right, so the next thing we are going to create now is to create a test data where we put a test data. All right, so we are going to create a new file. Now I'm being a little fast, but all the procedure on the piece of code you need to use, they are there on my website. So feel free to pause the video, feel free to open the website and follow step by step the procedure there. If you miss out anything, let me know in the comment box below this video. So I'm going to add a new class. I'm going to just click here. So this new class I'm going to add, I'm going to call it test iris data. So we are going to give a test iris data. Okay, so we are going to specify in test iris data, we are going to be specifying a new impute. The new impute is simply all the features, the petal length, petal width, sepal length, sepal width. Sometimes this can be confusing, but these are the four columns that we need to be specified, and our model is going to predict which cluster it belongs, and also the distances from other clusters, or in this case we are having 3 clusters. Alright, so the next thing, which is the final thing, is to make a prediction, and I'm going to copy the main method. We are going to add this code that takes this test the text data or the test iris data and then makes a prediction for us. So I'm going to save everything. I'm going to go back to program.cs. At this point, I'm going to just paste this. All right, so I'm going to just kind of shift this one a bit upwards. Okay. All right, so I'm going to shift this a bit downwards. We are creating, using a predictor, say predictor.predict, and we are providing text iris data.setUser, and then we are going to we are going to make prediction given this. Okay, so we are asking the model how likely it thinks that this belongs to this cluster. So you can actually change it to anything you want. It doesn't really matter. So cluster is given prediction.cluster.predicted cluster ID gives us a predicted cluster ID. There are 3 of them, and it gives us the 3 distances as an array. So I'm going to save everything, and I'm going to run this by just clicking on. Maybe I'm going to build it first, just because it's good to build your solution to make sure the build worked. Okay, so this is an error that occurs. It says ML.NET currently supports x64 and x86 processor architectures. So to solve this problem, just go to right click on your project and go to properties. So here we are going to change the I think we are going to change the settings. Build, let me check build. I can't remember. Okay, so you can see at this point we have any CPU. So we are going to change it to, and you'll say it prefers 32-bit. That does not make sense, because who uses 32 bits now? My system is 64-bit and this program is a 64-bit program. So I'm going to just right click and choose x64. That is the architecture we are going to use. And at this point, I'm going to save everything and I'm going to rebuild everything. So I'm going to right click and rebuild solution. And you'll see this problem is solved. That is how to debug a problem like this. All right, I'm going to close. Perfectly okay. I'm going to close this and I'm going to run the program at this point. So I'm going to click on start. And if everything is okay, it's going to tell us, given this test data, now it takes some time. So let's see, it's showing up the output right here. So it takes time to train the model. After training the model, it also takes time to execute to make prediction using this model. So let's give a couple of seconds. Hopefully everything is going to work. All right, so hopefully you can see this. I don't know how. Wait a second. It kind of is okay. So actually I'm gonna run again now. It's gonna be faster. So the output here is given. So at this point, if we've gotten to this point, you have this black screen while it's coming with the output. It says cluster 2. It says this impute belongs to cluster 2. And the distances is from cluster 1. From cluster 2 is very short distance, and from cluster 3, therefore it belongs to cluster 2. So we have this test data belongs to cluster 2. So I'm going to give you, say congrats to you if you've come all the way to this point. You've done noble. This is the first point. This is a no-brainer. It's very easy for everyone to follow. And the next steps now, we are going to now proceed to go into more details. We are going to be doing sentiment analysis. And believe me, this is how it works. It's not going to be more difficult, except that there are some theories I'm going to be explaining in more details in subsequent tutorials. I'm going to be talking about movie recommender systems. That is something used by Netflix and YouTube. Object recognition in images, image classification, and a few other things we are going to be talking about. So hit the subscribe button and make sure you always subscribe. Hit the bell icon beside the subscribe button. There is a bell icon. Hit on it so that you don't miss an update when a new lesson is made. I'm going to stop here. I'd like to thank you for viewing and also say we'll see you in the next lesson.